Today we're looking at balancing redox equations. The other day I was talking about redox equations without ever really quite mentioning what set a redox equation separate from all the other kinds of equations. And when we were looking at oxidation states or oxidation numbers, we found that those can change. And so in a redox equation, what we find is that the oxidation states of the elements on the reactant side will be different from the oxidation states of the elements on the product side. So for an example, in a reaction of iron reacting with oxygen to give you rust, or Fe2O3, we can see that the iron starts off in a zero oxidation state, the oxygen starts off in a zero oxidation state, the oxygen in the product starts off at a -2 oxidation state, and the iron in the products starts off with a +3 oxidation state. So we see that the iron is changing oxidation states, and so is the oxygen. And that's how we're going to know whether or not it's a redox equation. Take a look at any acid-base reaction, HCl plus NaOH giving NaCl and water, and you'll find that the oxidation states are staying the same. So that is not a redox reaction, but rather an acid-base reaction. Here, I want to take a look today at balancing redox equations, and what we find here is that this is a pretty easy one to balance, right? We've got 2 oxygens in the reactants, 3 oxygens in the products, and so if we simply multiply the products by 2, now we've got 6 oxygens in the products, so we can balance that out by putting a 3 in front of the oxygen. We now have 4 iron, so we can put a 4 in front of that, and we are done, right? That is easy enough to do by what we would call inspection. All right, so right after this, I'm going to take a look at balancing redox reactions, which are significantly more challenging.